Hello everyone, myself Kamna Singh, Assistant Professor in Computer Science and Engineering Department in Akgec Engineering College. Today we are going to discuss the topic RSA. RSA is nothing but it is a public key cryptography. Let's discuss. First of all, we have to know about the cryptography. Cryptography is a secret writing, or you can say the technique of the securing the communication of from sender to receiver. There is a two terms, that is a plain text and the ciphertext. Plain text, whatever message you are going to design, that is called the plain text, and the ciphertext, you can say the meaningless code for sharing the information over the net. So there are, in the cryptography, there are two techniques are used. There is a asymmetric key cryptography and the symmetric key cryptography. In the asymmetric key cryptography, there is a two keys are there, private key and the public key. And in the symmetric key cryptography, there is a only one single key, or you can say that is the shared secret key for both the encryption and decryption. Now let's discuss about the symmetric key encryption. In the symmetric key encryption, you can see here there is a plain text. Plain text means whatever you are going to design, or you are transmitting the message to your friend, that is your, whatever you are creating the message, that is your plain text. Fine. And there is some encryption algorithm, and the secret key is applying over here, and some encryption algorithm is also there, and then you can get the ciphertext. Here again the secret key will be there and the decryption. This secret key is the pair of some integers, or there is a numbers, fine, and there is a plain text. At the receiver side you can get the plain text. So actually how you are going to, in the symmetric key encryption, both the keys are the same. At the sender side and the receiver side, both the keys are same. And in the asymmetric key encryption, today we are going to discuss this asymmetric key encryption. This is the part of the cryptography, and cryptography is the secret writing. So in the asymmetric key encryption, as you see in the symmetric key, both sender and receiver shared the secret key. Means both having a same secret key is there. Here in the asymmetric key encryption, there is a two keys are there, that is a public key and the private key. And public key is applying for their, actually public key is what? That is announces by the user or by the sender or a receiver over the public. That means this particular public key is known by everyone on the network, and the private key is the secured key which is known by the only the user. You can see that just simple example, that there is a user ID and password. In the user ID, everyone knows that is your public key, and when you are using the password, then there is a private key, and this particular password is known by only you. Fine. In the asymmetric key encryption, suppose there is a plain text is there. So plain text, you can see there is a message. Fine. And how you are applying for the ciphertext. This fine, the plain text is converted into the ciphertext. This message, this particular message having applying the encryption with the public key. So you can write here, you are applying the encryption and there is a public key is there applying to the message. So this will be as a ciphertext. And when you want at the receiver end, you needed the message or a plain text is there. So at that moment you have you can get the ciphertext here. So there is a ciphertext, and now you are applying the decryption algorithm. This decryption algorithm is there. In this particular decryption, you are using the private key. So this can be a simple formula for the asymmetric and symmetric key encryption. Every time these public key and private key are the shared secret key, you can say, that is public key is known by the everyone on that particular network, and private key is the secure within the particular user. Now, let's discuss the topic RSA. RSA is actually the public key cryptography. Public key cryptography is used for the encryption and is known to everyone, while the private key is for the decryption and must be kept secret by the receiver. So RSA algorithm, why it is named as, because there are three scientists, that is the Ron, Adi and Leonard. That's why they are developing in 1977 or RSA or a public key cryptography. That's why its name is RSA. Fine. This is the simple example of the RSA algorithm. There is a sender and receiver. Fine. This is a secret text, or you can say a simple message is there. This is simple message, you can say, or a plain text is there. In the plain text, you are applying the encryption algorithm, and there is a recipient public key. You can see here, that is the public key. You can write it here, that is the K, but it is the recipient public key. Fine. And there is a recipient private key, or this particular key you can call as recipient private key. Fine. So this particular key, it means, always remember, in the RSA, when you are going to apply the encryption, at the encryption time, the public key of the receiver will be used for the encryption, and at the receiver end, when you are deciphering or decrypt that particular data, that moment receiver, at the receiver side, receiver uses its own particular private key. Fine. So the formula you can derive from this, as we derived here, as in this asymmetric key encryption, we can derive it here as an RSA. So, for the cipher text, when you are writing here, that is a cipher text. So, cipher text is applied here. This, you can get the encrypted data or a cipher text. This cipher text, how you are collecting this? Because there is a message, and this, on this particular message, you are encrypted, some encryption algorithm you are applying. And with which type of key? That is the recipient public key. So, you have to write recipient public key as a message. So, you can get the cipher text as the sender side. Now, at the receiver end, you can get the plain text, or you can say the message. This particular message or a plain text, this message is equivalent to your plain text, or you are going to create whatever the text is. So, this is the message. Fine. And the public key is what? Here, you are going to decrypt that. So, the decryption key used, and this decryption key is like K of receiver private key. So, receiver private key is there, and on which we are going to apply whatever cipher text we are getting from the sender side. So, this is the cipher text. This is a simple formula you can get with the RSA, public key and the private key. So, actually in the sender side there is a cipher text, at the receiver side there is a particular decryption. Now, in the asymmetric key means what actually? If the person A wants to communicate the message to the person B, then the person A or a sender encrypt the message with the person B public key, and the person B decrypt the message using its private key. So, this is the simple phenomena of the RSA. Let's discuss about the numerical problem, because in every particular semester exam or a session exam, always there is a RSA algorithm numerical question. So, let's discuss about the numerical. This is the RSA algorithm. You have to memorize. It is very simple. The 3 steps are there. First step is the key generation, and the second step is as an encryption, and the third step is decryption. These 3 steps are only for the RSA algorithm. So, the first is the key generation. Key generation means you are going to generate the public key and the private key, and public key and private key always in the pair. Let's discuss. First is the key generation. First of all, you have to select the 2 prime numbers, whatever prime numbers, you know that. Those are prime numbers, and these 2 prime numbers are, we are selecting by the user or by the particular administration. Now, the second step, you have to calculate the n. N equal to P into Q. That is what? Product of the prime number you are selecting. Next is the Euler-Tochin function, that is the phi n, and phi n you can calculate with P minus 1 and the Q minus 1. Phi n equal to P minus 1 into Q minus 1. P and Q are the prime number. Now, the tricky part is that you have to find out the encryption key. Actually, the E is the encryption key and the D is the decryption key. So, the E encryption key you can get with this particular formula. That is, E lies between the 1 and phi n. Or you can say that the GCD of the phi n equal to 1. If you applying this GCD of E of phi n equal to 1. If you are calculating this equality, so you can get the E. And GCD you can calculate. Next, and the decryption key. For this decryption, you have to calculate this formula. D into E equal to 1 mod phi n. So, in this particular key generation, you have to, first of all, you have to find out that whatever the prime numbers P and Q. Then you are going to calculate the N, that is P into Q. Then again the third step, you are getting this phi n. Phi n is the P minus 1 into Q minus 1. Next, the tricky part is how you are going to calculate the encryption key and the decryption key. This encryption key you can calculate with the formula GCD of E phi n equal to 1 and the particular D or decryption key you can get with this D into E 1 mod phi n. Fine. Now, in the public key, so you can get in the key generation, what is the motive of this key generation? That is what? Public key and private key. So, the public key is what? Public key is the NE and the private key is the N and D. Whenever you can get in the question, you have to find out the public key, you have to find out the encryption key or a decryption key. So, E is simple E, but if we are talking about the public and private, then these are the pair of the numbers. Fine. The pair of the numbers is like public key is the N of E and the private key is the N of D. Now, the second step of the RSA algorithm, you are going to calculate the encryption. Encryption means you are going to collect the ciphertext. Ciphertext you can get whatever message is there with C equal to M to the power E mod N. And in the decryption mode, means at the receiver end you are getting the plain text or a message, because you are getting the ciphertext. How you are get your original message? With this formula, that is the M equal to C to the power D mod N. So, always remember in the RSA, you have to key points are there, that first there is a P and Q, and the second there is a N, that is P into Q, and the third step, that is phi of N, that is P minus 1 into Q minus 1. This is the shortcut method of the RSA. Next, you have to calculate of GCD of phi N of E equal to 1. So, you can calculate the E, and then you can get the private key and the public key. Private key is what? D and N, and the public key is E and N. This will be the simple 5 steps for this RSA. Fine. And one more thing is there, ciphertext you can get the M to the power E mod N, and message or a plain text you are getting with C to the power D mod N, where N is what? N is here, that is a P into Q. So, M equal to C to the power D mod N is there. Fine. Now, this is the simple flow chart that how you remember these steps. First of all, enter the prime numbers P and Q. Always there should be a prime number, and then calculate the N equal to P into Q. Next, the public key finding out. Public key, how you are going to calculate? With the GCD of phi of N of E equal to 1. Fine. And there is a private key E mod phi N. So, D into E mod phi N equal to 1, or D, how can you calculate? D into E equal to mod phi of N. So, ye aapka, there is a D into E mod phi N equal to 1. Or simply you can write D into E mod phi N equal to 1. For encryption, there is a plain text and the ciphertext. So in the RSA, there are some steps to remember. These are the key points to remember. These steps are what? The first point, whenever actually what you are going to do, there is a plain text, you are going to convert into the ciphertext after applying some encryption key, and then at the receiver end there is a some particular ciphertext is there, and you are applying some decryption key, and you can get that particular message or a original message that you are going to create it. Fine. Now, if the message is just like the alphabets, like hi, hello, welcome, whatever the message is there, if in the particular question, that particular message is not saying that H, A, I, hello, whatever the value is, it is started as an alphabets like A equal to 1, B equal to 2, and Z equal to 26, and whatever. If it is writing here, then you can calculate the high value is like this with this particular. If by default it is not written, so by default you have to use the ASCII 7 encoding scheme. ASCII 7 means there is a capital in the uppercase A to Z value is, you have to remember this number. In the uppercase A to Z is 65 to 90, and in the lowercase 97 to 122. It means what? If my message is A and B. A, B message means what? In the lowercase 97 plus 98, whatever the value is, that is my message. And if I'm writing here as an A and B and a capital letter, then there is a 66 plus 65. That will be the my A and B uppercase. Fine. And the one more thing, you just memorize this technique, because every time when we are going to calculate the RSA, we have a calculator, but we cannot calculate the very high number or a very, there are so many power of the numbers are there. That time you cannot calculate with this calculator. So this is the trick. You have to write down this, or something you can take a snapshot. This is the trick of the RSA, that how you are going to calculate the m to the power e mod n. Suppose the message is like 63,000 something, a power of 7. So the number will be very, very large. Then how you are going to calculate? So this is the trick part, that how you are going to calculate the x mod n. X mod n, nothing but it is the, when you are going to calculate the m to the power e mod n as a ciphertext, or C to the power D mod n for a decryption. So you have to memorize this. If you have to calculate the x mod n, x mod n can be m to the power e mod n or a C to the power D mod n, doesn't matter. This x mod n, first you have to divide this x by n. Fine. When by the calci, when you are dividing this, there is a some number will be there, some particular integer number and some decimal part. This particular decimal part you have to discard. This particular number part you have to discard. Simple. After this whatever the value is there, you have to multiply it with the z into n. Whatever value comes, suppose there is a y comes. So here is the x, no? So x minus y, that will be your answer. Always remember this trick for calculating your particular ciphertext or a plain text. Fine. These are the tricks. The first, whenever you are going to apply for the RSA, first the prime number is there, then n, then phi n and GCD. Then calculate the private key and public key. C value means ciphertext is this one, and the m equal to C to the power D mod n. And the one more thing you have to know, that is what? Calculating how you are going to calculate the x mod n. Now, let's taking the example. Suppose that this particular question is coming in your particular exam. Encrypt the message hi. When it is in the single quote or a double quote, doesn't matter. You have to use only this particular message, hi. Hi is the in a capital letter, and there is no written equation is there, that is starting from the a equal to 1, b equal to 2, c equal to 3 or whatever. It means we have to calculate hi as a ASCII 7. Fine. So First thing I have to know that it is high message will be going to the sky 7. Now, there is some prime number is given p equal to 7 and q equal to 3. Find the following, that is a encryption key find out करनी है and decryption key, cipher text, plain text, public key and private key. So you know that the decryption key DE mod phi n equal to 1. So what are the formula for encryption key? That is what? For the encryption key, that is GCD phi of n of E equal to 1. First thing. For the decryption key, D into E mod phi n equal to 1. Then you can calculate the D, because in the first step you already calculated the E value. Cipher text is what? C equal to m to the power E mod n, where E is the encryption key. And the plain text m equal to C to the power D mod n. Public key is what? That is the pair with the n and E. And private key is the pair of the n and D. So you can calculate the public key, encryption key and decryption key. Now the first step. In the first step, first is what? P and Q. Selecting the P and Q. Here P equal to 7 and Q equal to 3. In the step 2, you have to calculate what? P equal to P and 7 already given. Then now you have to calculate this as an N. N equal to P into Q. That is what? 7 into 3, that is 21. In the step 3, you have to calculate of phi of N. That is P minus 1 and Q minus 1. P minus 1 and Q minus 1. P 7 means 6 and Q 3 minus 1, that is 2. So phi n value is 12. Fine. Now in the step 4, this is the tricky part. How to select the E? You have to select the E. E can be selected by the trial and error method. Fine. So we have to know the equation is what? GCD of phi n of E equal to 1. This equality should be solved. So here GCD and the phi n value is what? That is 12. E equal to 1. When I am writing here, that is I am with a trial and error, equal to 1. This is good that we can use the encryption key as a 1. For the attacker point of view, we are not going to take equal to 1. Fine. In the second, equal to 2. There is a trial and error method to calculate this equality. Now equal to 2 is there. So the GCD of 12 and E value is 2. It is not equal to 1. Then equal to 3. GCD of 12 of 3 is not equal to 1. Again GCD. And the equal to 4 means GCD of 12 and 4. It is again not equal to 1. Then equal to 5. GCD of 12 and 5 is equal to 1. So we are selecting that our E is 5. Fine. You can calculate the E. Now the first step, E I can get, this is the E. After the calculating the E, you can also find out the D. Hai na? So how you are going to calculate the D? D into E mod phi n equal to 1. And now I know that D, E is what? Now I can calculate the E is 5. So this is the 5 mod phi of n. Phi of n means what? That is already calculated. That is the 12. Mod 12 equal to 1. Right? 5D mod 12 equal to 1. Again the trial and error method will be there. This trial and error method, D into 5 mod 12. So you can write it here, D5 mod 12 equal to 1. When I am writing here, D equal to 1. 1 mod 12, that is 1, but we are not going to take that as value. Then D equal to 2. D equal to 2 means 2 into 5. That is 10 mod 12. Not equal to 1. D equal to 3. 3 means what? 15 mod 12. Not equal to 1. Fine, now 15 mod 12. 15 divided by 12. So, it cannot be as in. Then D equal to 4. 4 means what? 4 into 5? 20. 20 mod 12. Not equal to 1. 5. 25 mod 12. That is equal to 1. That is equal to 1. So, we can calculate the D equal to 5. My E equal to 5 and the D equal to 5. Both encryption and decryption key I can get. Now, the calculation of the ciphertext. When you are using the ciphertext is M to the power E mod N. Fine. Ciphertext means now we are going to calculate this one, third number. C to the power M to the power E mod N. M is the message. First of all, we have to know this high message. High message is actually what? I already calculated this high number. That is a 72 plus 73. That is 145. Why you are calculating is here? Because the 67 to 90 for the uppercase letter, high value is this. Then you can get the 72 plus 73. Because in the sky 7, A is started from the 65. So, our plain text is M to the power E mod N is there. So, you can get 144 5 power 5 mod 21. So, here you are going to calculate the trick. That is what? If you have to calculate the X mod N, first you have to calculate the power of 145. That is this one. Even though it is written very high, but it's simple. Again, the mod 21 is there. So, you can calculate the mod 21. Whatever the Manteesa part, you can calculate into with this, into 21. This part is coming. Next, this part is minus by this one. Z into N and the X minus Y. X minus Y. Then you can get the answer. That is the ciphertext is 10. Fine. So, this is your overall RSA. With this particular example, you can see here that is the same procedure will be followed in this encryption and decryption calculation. Main RSA advantages and disadvantages. The main advantage of the public key cryptography, it is very robust and the less suspectable. But the disadvantages, because the public key cryptography, so the computational requirement is there and it is slower than the symmetric key.